Very good day, dear students. So I'm Shomadeep, your faculty for robotics. Now, as I promised earlier, after the installation, after the program uploading session, a very short session, and the completion of the hardware parts, now we will be straight away moving into the software parts. Now, by software parts, what do I mean is that we'll be moving into the coding section, like how to code and what are the correct syntaxes, what are the correct ways to code. All these will be dealt with in these further sessions. Okay, so there will be hardly 2 to 3 or 4 sessions maximum in which I will be teaching you about the format of the coding. Okay, and after that, what we'll do, we'll see some simple codes like such as examples. Okay, and then what we'll be doing is we'll be starting off with small projects, easy projects, right, as everybody does, and we'll be shifting our domain towards the difficult projects or better products. Okay, so this is the way that we'll be dealing in our further classes. So let us move on. Let me show you the screen, and let us move on into the syntaxes. Basically, let us see what we have. So here we are. Let us begin our session in the programming part. First, when we're talking about programming in Arduino IDE, what we come across, the one of the most important and very frequently missed part. Now, why I'm saying very frequently missed is that because these mistakes are basically what the beginners do, that they miss some of the brackets. Okay, if they miss some of the brackets, then what happens? The code doesn't work. Okay, it will show you error. All right, so these mistakes, these errors are easily solvable, not to worry about that. And I can guarantee you everybody will make this mistake. So don't be worried. Okay. Everybody is going to make this mistake at some point. Okay. Even after learning also, you can make a mistake in giving the brackets and all. Okay. So no need to worry about it. All right. So let us see. Let me show you the full screen over here. Yeah. There are two types of brackets used in the Arduino code. So which are listed below. Number one. Number one is they are the parentheses. Okay, or in mathematics what we call the first bracket. Okay, and number two, they are the curly brackets. All right, where are parentheses used? You see, the parentheses brackets are the group of the arguments such as method, function, or a code statement. Okay, these are also used to group the math equations. So for example, if you are giving a condition, okay, if you are giving a loop, beginning a loop, okay, or ending some loop, then what you are going to do is you are going to use the parentheses. I'll show you when we'll be doing the coding. I'll be showing you that. Okay, all right. Where the curly brackets are being used, curly brackets, they're basically the code is enclosed in the curly brackets. So we always require closed curly brackets to match the open curly bracket in the code or sketch. Now this thing you see, the thing, the first one is the open curly bracket, and the second one is obviously the closed curly brackets. So one for each, like it comes in pair basically. So when you open a curly bracket, you also need to close a curly bracket. That's the rule. That's the very basic rule of any kind of language you do, any kind of programming you do. So what we are going to do is whenever you are opening a curly bracket, simultaneously you close the curly bracket. Okay, then you can press enter, or then you can write your code or write the lines of code inside it. So in that way, what we are going to avoid is we are going to avoid the mistake of like missing out of one curly brackets. Okay, in that way. All right. I hope you got it what I'm saying. Okay. Whenever you are opening a curly bracket, close it at that moment only, and then inside it, like take the cursor inside it, and then write the code or write the problem statement, whatever you are writing. Okay. Then line comment. Now, this line comment basically, there are two types of line comment. Okay. One is the single line comment. One is the multi-line comment. See, the purpose of having a line comment is basically to know the purpose of that line of code. Okay, that is the basic purpose. All right. Now, this line comment can be of one line or of multi-lines. Single line comment, the text that is written after the two forward slashes. Okay, remember the single line comment is given by the forward slashes. Okay, are considered as the single line comment. The compiler ignores the code written after the two forward slashes. That means, for example, you have written a two-line code. Okay, now somehow or the other you want to test that what is the output of the first line of, all right, and what is the output of the second line of. Now, to check the output of only the first line of code, what you need to do is you need to omit the second line, or else what you can do is not omit the second line, keep it in, okay? Or else you need to rephrase it or remake it again and again, or rebuild it again and again. So in that manner, what we can do, we can comment the line, okay? We can make the line as a comment line. So by making it as a single line comment, what we are going to do is we are going to disable basically the second line. Okay, that's what we are going to do. Disable the second line. Fine. Okay, the comment will not be displayed in the output. Okay, such text is specified for a better understanding of the code or for the explanation of any code statement. Okay, the double forward slashes, two forward slashes, they are used to ignore some extra lines of code without deleting it. Okay, that is what is the purpose, basic purpose of it. Then next, let us come to the multi-line comment. So in the multi-line comment, you can see how it is done. I have specifically highlighted it for you. Okay, you can see the forward slash, then the star, and something written in between. That is in this case the multi-line comment, and then again the star and forward slash. Okay, this is how it is being written. It is written. Okay, the multi-line comment is written to group the information for clear understanding. Okay, it starts with the single forward slash and an asterisk symbol. It also ends with the forward slash and asterisk symbol in the reverse manner. It is commonly used to write the larger text. It is a comment which is also ignored by the compiler. So the purpose of this comment line is both of them will be ignored by the, whatever the content is within the single line comment or multi-line comment will be ignored by the compiler, right? Okay, but the thing is, both have a little bit of difference in between in the syntax also as the purpose also. Okay, so keep that in mind, and don't worry, I'll be showing you how to use this. Now, this is the coding screen here. And what do I mean when I say coding screen? When you open the Arduino IDE, you would be seeing this type of screen. Okay, all right. You see the coding screen is divided into basically two blocks. Okay, you see this is one block, the preparation block, and this is the one block execution block. Okay, let us go into great details into one by one into these blocks. Okay, number one, if you see the preparation blocks, so when you talk about the preparation block, so preparation block is what prepares the controller for the execution of the. Okay, you see this preparation block is what starts with void setup. That means we are setting it up. Right now, what we are doing, what is our aim? We are setting it up. Setting it up for what? Setting it up for the execution of the code. Understood? Okay. It is written over here. Can you see the comment line over here? Right? That is the use of comment line. So this line is being ignored by the compiler, but we can read it. Okay. This is the typical Arduino screen. This is the typical Arduino screen that you are going to get when you open the Arduino IDE, Arduino coding screen for the first time. Okay. It's written, put your setup code here to run once. That means this code, this part of the code, or I should call it this code snippet, this will run once, only once it will run, and it will set up your Arduino board, your pins. Okay, here we basically what we do, we mention the pins and all. I'll be showing you in the further future classes. So we set up the pins, which pin should act in what way, in what manner, which pin should be high, which pin should delay a bit, which pin should be low. All these setup things are being done in the void setup or the preparation block. That is why, dear students, it is known as the preparation block. Okay. The next part of the code is the execution block. It starts with void loop. That means there must be something that starts with a loop or that runs in a loop. That means there must be a part of the code which we want to run it in a loop. See, put your main code here to run repeated. Here it is written as run once. Here it is written run repeated. That means the part of the code which must be running repeatedly, one by one, one after one, it should be over here. Understood? I hope this is clear to you. Okay. In the further projects, in the further sessions, in the further classes, we'll be talking more about it when we'll be executing. Okay. Now, for the first thing that we have here is the setup block, okay, or the preparation block. Let us learn about it. Let me show you it properly. Yeah. It contains an initial part of the code to be executed. The pin modes, libraries, variables, etc. are initialized in the setup section. Okay, what do you mean by pin modes? Pin modes means when it should be high, when it should be low. That means when it should turn on and when it should turn off. Those are called the pin modes. That's the most important thing. That's the most important part we do in this section of the code. Libraries, if you want to add any library, if you want to include any library, if you want to detect any kind of libraries in our code, we want to use any kind of libraries in our code, we need to define it over here, or we need to rather call it over here. If we have the libraries, you need to download it, save it somewhere, and call it up in this section. Okay. And then comes variable. What do you mean by variables? Any variable you want to define, you want to use it while coding, should be or must be defined over here. Okay, so these are the things and more what are like defined in this or mentioned in this section of the code. Okay, it is executed only once during the uploading of the program and after reset or power up of the Arduino board. What does that mean? What does that mean? That means when you are uploading the when you have connected the Arduino board to the computer and now you are connecting, you are uploading the code, what is happening? That is the time when the compiler is realizing this part of the code and it is getting executed. Understood? Okay, so it gets executed only once, all right, while uploading. Okay, zero setup resides at the top of each sketch. As soon as a sketch means, dear students, sketch means a file that we are running. Okay, it's called in Arduino language, it's called as a sketch. Okay, so as soon as the program starts running, the code inside the curly bracket is executed in the setup and is executed only once. That is the basic function, that is the basic purpose of a setup block. Okay, okay, understood. Then comes the loop block, and by loop block, dear student, what we mean? The execution block. Okay, where void loop is. All right, what does it do? The loop contains statements that are executed repeatedly. The section of code inside the curly brackets is repeated depending on the value of the variables. Now, how many times and when to repeat, it must be given by us with the code. Okay, if we define any variable in the setup block or in the defining block, the first block, then the void setup that we say in the code. So after that, we can assign any number of value, any number of times the code can be run within the void loop or the loop. That is the purpose. Now, so this is the case of the setup block and the loop block. Okay, so the very in a gist, very simply, we can say that when you want to configure something, okay, you want to set it up, then you write it down in the void setup. And when you want to run something like in the code repeatedly for a number of times, you can write it in the void loop. Okay. Now, time in Arduino. Now, this is an interesting thing, dear students. Now, it's a very simple thing. You can remember it. the time in Arduino programming is measurement in a millisecond. Okay, it's measured in a millisecond. So what do you mean? See, first of all, we all know that 1 second is equal to 1,000 milliseconds, right? So now whenever you want to include anything in seconds, you need to calculate the millisecond, like how many millisecond it is making up. Okay, and you need to put the value of the millisecond. Now, for example, I'll give you a very simple example. When you are trying to blink an LED, okay, and you want to set a pattern of it. Okay, pattern of what? Pattern of blinking the LED. You want that the first blink and the second blink, there should be in between, there should be a gap of 5 seconds. Okay, so what do? You put the command for for example, you are using the 13 pin. Remember what is the 13 pin, dear students? Digital 13 pin, D13, the inbuilt LED is there. So what you did is that pin mode 13, okay, so it should be high and then it should be low. So it doesn't make any sense because it should be on and it should be off at the same time. So how it will be making sense if you include a delay in between. That means if it delay, you include a delay of 5,000. That means 5,000 means 5 into 1,000, that is 5,000. That is 5 seconds, right? If you write 5,000, it is 5,000 milliseconds and it is 5 seconds, right? It includes 5 seconds. So that means you are conferring that the LED should be on and then it should stay on for 5 seconds, that is 5,000 milliseconds, okay? And then it should be again off. Understood? This is the thing. Okay, this is how the time is being calculated. I gave you a very simple example. Okay, see. So this is the LED blink program, and trust me, this is everybody's first code in Arduino. Okay, whenever anybody learns Arduino, the first programming that they learn is to blink an LED. That's it. Okay, that's period. So let us see the steps to open such an example. Achha, by the way, if you want to learn, there are some pre-provided examples in Arduino IDE also. Okay, what you're going to do, you can go to, I will show you later on, but now I've written the steps for you. That's for your convenience. No need to write it down. You can just see it in the Arduino board. Click on the file button. Okay, file button, which is present on the menu bar left side. Okay, upper left side. Then click on the examples. There you will see many pre-programmed files. Okay, now the most basic one is the blink program. You can click on it and this kind of program, this kind of screen will appear. Okay, this kind of code will appear. Okay, if you see this, can you see void setup? It says pin mode LED built-in output. Okay, you can also write it down for 13. Okay, and if you write LED built-in, it automatically takes the D13, that is digital 13 LED. Okay, pin. Then in void loop, we have written digital write LED built-in high, then delay 1,000, then digital write LED built-in low, then delay 1,000. What does that mean? If you understand the syntax of this code, everything will be easier for you. Try to understand. When we write first in this void setup mode, what we do, we are setting up. What we are setting up? We are setting up that which pin we are using. Try to understand it very carefully. What we are setting up over here? We are setting up which pin we need to use. So firstly, what we are doing is we are setting up the pin. So pin mode, we are setting LED built-in to be the output. Okay, we only need an output. We don't need to give any more instruction and need any kind of like input over there. We just need the LED to blink. That's it. That's the most simplest program. Okay. After that, if you see inside the void loop, what we have written, digital write. That means digital write means either on or off. Now, at first instance, we obviously want to see the LED on because off LED is always staying off. So how can you like see off, make a change by writing the off code, right? So we need to blink an LED. We need to switch it on. We are writing digital write, LED built-in inside the parenthesis, LED built-in. High means for a digital pin, high means right. Any amount of voltage, high means on. Then we are writing delay 1,000. What does the delay 1,000 means? It means after switching it on, let let it be on for 1 second. 1000 means 1 second. Okay, 1000 means 1000 milliseconds, so it is 1 second basically. After that, what else will do? Digital write, LED built-in, low. That means after 1 second, switch it off, let it be off for how much? For how much time? Delay 1000. That is 1000 milliseconds. Again, 1 second. I hope it is clear to you by now. Okay, how we write the code. This is the simplest example, and trust me, any person, any number of person you meet, they will tell you the first code that they did in Arduino was the LED blink. Okay, let us move forward. See the void setup. What we'll do now? Now carrying forward with the earlier example that we just now have studied, what we are going to do? See, the pin mode. We have written pin mode. Now we are setting up the mode of the pin to be the output, right? The specific pin number is set as the input or output in the pin mode parenthesis function. Okay. Now the syntax to write it is the pin mode. Then inside the parenthesis, pin and mode. What do you mean by pin and mode? Look at it very carefully. Pin mode. Inside the parenthesis, we have written the pin. What is the pin? LED built in. That means D13. Okay. And what is the mode? Output. So we have written the pin and the mode. Understood? This is how the syntax is. This is how we write. Here. So pin is the pin number. We can select the pin number according to the requirements. And what is the mode, dear students? We can set the mode as input or output according to the corresponding pin number. Clear? Okay. Now, for example, we want to set the 12th pin, that is digital 12 pin or D12 pin, as the output pin. What will we do? Pin mode. Very easy. Inside the parenthesis, inside the bracket, 12 out. That's it. That is it. As simple as that. Okay. Next. Now here comes the digital write. Okay, so as you have seen in the previous example also, where the digital write is used, you know already. The digital write function is used to set the value of a pin as high or low, right? Right. What does that mean? Basically, that means if you want to assign a value, for example, by digital value, I mean either on or off. So if you want to switch it on, you write high. If you want to switch it off, you write low. Okay, this is how the digital pin values are being controlled by using the digital write. Okay, so in between there are no values. It's either on, that is high, or either off, that is low. That is it. That's what the digital write pin means. Okay, so where high, it says the value. You see, it's written. It says the value of the voltage for the 5 volt. For the 5 volt board, it will set the value of 5 volt, while for 3.3 volt, it will set the value of 3.3 volt. Okay, whichever the case. All right. Low means it sets the value to 0. That is the ground level value, that is 0. Now, if we do not set the pin mode as output, the LED may light dim, because it's not a proper way to set up. If you want to blink the LED, that is the inbuilt LED or 30th number LED, so you must properly configure it to be an output. That is how it will be shining to its full capacity, full potential. What is the syntax? Dear students, note it down. The syntax is digital write, and inside the parentheses, you first write the pin number, which pin you want the value to put in, and then comes the value, that is high or low. Okay. I hope you have understood this. Okay, this is how it is being written. The code is being written. Now, pin, we can specify the pin number or the declared variable over here. Now, for example, digital write 13 as high. Okay, and digital write 13 as low. That means the high will on the LED and low will switch off the LED connected to the pin number 30. That is how we are writing it. Now comes the fun part, delay. Now delay with like we can experiment like in numerous numbers, okay, with the delay function, because it basically what it does, what it says, how its name project is delay. What it does is basically delay the next command. So the delay and the parenthesis inside it. So the delay function is a blocking function, pause a program from doing a task during the specified duration in milliseconds. Mind it, everything we do here is in milliseconds. Okay. Okay, we can calculate it how much seconds are being used over there. So for example, delay 2000. What does delay 2000 means? Very easy, you all know it by now. Delay 3000 is 1 second is 1000 millisecond, so it will provide a delay of 2 seconds, right? 2000 means 2 seconds. Okay, so the code is, if you are writing digital write 13 high, this line sets the 13th pin, that is the LED, to be high, to be on. Then we are delaying it, delay 2000. That means for 2 seconds, it will be on like that only. Okay. After that, if we write delay write 13 to be low, it will switch off the LED. That is the 13th inbuilt pin. Okay. Again, delay 1000. That means for 1 second, it will be switch off. Now you can continue this. Okay. You can continue this thing. All right. You see, in this code snippet that is written over here as an example, what I have provided you, here the LED connected to pin number 13 will be on for 2 seconds and off for 1 second. The task will repeatedly execute as it is in the void loop. Understood? So it is not ending over here. Since it is inside the void loop, we have provided it inside the void loop, dear students. So this task, what task? Continuously, the LED will be on. We will be on for 2 seconds. Again, off. Will be off for 1 second. Again, it will be on. Will be on for 2 seconds. Again, it will be off. Will be off for 1 second. This cycle will keep on repeating. Okay, and you can play with it. You can literally play with it any number of times. You can just put on the delay and you can do anything. So like when I used to learn Arduino, this was a very fun task for me. So playing with the 13th LED, okay, we can repeat the thing. We can put the delay in anywhere and we can play with it, and we can perform, we can blink it in any pattern we want. Okay, so this was the fun. All right, so this is a full-fledged example that I have provided you. You see the code over here. In void setup, what we have done, we have written the pin mode. See, opening a bracket, closing a bracket. Very important. Okay. Void setup, 13 as output. So see, this is a command line usage. All the things that we have learned in this session is summed up in this whole example. To set the output mode of pin number 13. Then inside the void loop, what we have done, digital write 13 high, then delay for 4000. That means in the command line, you see 4000 for 4 seconds is equal to 4 into 1000 milliseconds. This I have put in the command line for you. It's not a part of the code. The compiler will ignore this. Okay, ignore. So digital write 13 low and delay 1500. It should be a multiple of 1000, like 1000, 1200, 1100, anything, but more than 1000, because the minimum value is 1000 because it is 1 second. Okay, and for us human beings, we cannot perceive anything that is less than 1 second. Okay, we would not be able to notice it. That is when it is happening. Understood, everybody? Okay, I hope you've understood. So this was it. Okay, this is it. This is the most simplest program. You can find it in the example also. You can modify it, use it, and do it yourself. So I hope you have enjoyed the session. Now we are full-fledged into the coding part. So meet you again. See you in the further sessions. See you in the next session. Okay, with more programming to do and with more understanding to do. This is it. Thank you very much, dear students, for being so patient. Let's meet in the next class.